Hello, I just wanted to review exponential functions for you before we do the quiz. In case you had any questions about exponential decay or, in this case, half-life. Half-life occurs when you have some sort of a substance and over a particular period of time it will cut in half. So this example would probably say something like I have 500 grams of a some sort of a radioactive isotope, and its half-life is that it cuts in half every 20 minutes. So this means when the number of minutes reaches 20, there will be half of the material left. So it will, so once this reaches 20, it's the same thing as multiplying it by a half once. After 40, it would be like this was a 2, and the 500 original grams would cut in half twice. And I'm just trying to make it clear why we write this kind of formula for a half-life problem. We also do it for doubling problems as well. Let's say I wanted to rewrite this as an annual percentage of growth or decay. Annual growth is written in this form. So in this case, in order to change any kind of a formula into annual, I just take the part of the formula that I don't want to be there in the long run, which in this case is this 20 and this 1/2, and I'm just going to simplify it using my calculator, and we will get y equals 500 times something to the x power. This will be our annual formula. So this was like a half-life example. I'm going to convert it into a annual example. So for this I need my calculator. I got a new one here. I'll put that over here. So using this calculator, I'm going to type in 1/2. I'm going to type in alpha y equals to access the fraction mode and choose fraction. I'm going to write 1/2 to the power of 1/2 whoops, didn't mean to put that there. So the power of 1/2, oh, not 1/2, 1/20th. So what I'm doing is I'm taking this 20th out as a 1/20th, and then I'm raising the 1/2 to that power. And if we calculate that, hold on. Let me try that again. 1/2, or 0.5, to the power of 1 divided by 20 should equal 0.965936. Let me move this over a little bit so it can fit the entire thing. 363,289. So this would say that there would be a decay of about 3.5% of our radioactive isotope every 1 minute. So this would be an annual rate. So this is converting to an annual rate. From annual, we can convert to any other type of a rate. First, we'll convert this into a monthly rate, and then we'll show how to do an exponential rate. So if I wanted to make this a monthly rate, what I'm going to do is I'm going to change this exponent by multiplying, making it into a 12 over 12x. Pretty much I'm gonna multiply it by 1, which is what 12 over 12 is, and I'm going to bring this, the 12 in the denominator, on the inside, and the reason for that is a monthly formula will say y equals 500 times 1 plus or minus. In this case, it's going to be minus because it's less than 1. Some r value over 12 to the 12x power. All right, so the way we're going to do that is we're going to simplify these together so that the 12x stays outside. So I'm going to raise that decimal to the 1/12th power. And we're going to get y equals, so this is changing to a monthly rate, 500 times 0.9971160 533 to the 12x power. This is almost in monthly format. I still have to write it as a 1 minus, so 500. So I'm going to write -1 into. I'm going to take my previous response and write -1 to see that this is 1 minus 0.0028839 467. So I'm trying to rewrite it in this form. So I just separated this into 1 minus the number that would generate that value. All of this is to the 12x. And then I need this to be over 12. So I'm going to put it over 1. And to make it over 12, I just have to multiply it by 12 on the numerator and the denominator, which is the same thing we kind of did before where we multiplied by 12. And then we get y equals 500 times 1 minus, let's multiply that by 12. .034600736. All of this is over 12 to the 12x power. So this is the monthly decay rate of about 3.4% or 3.5%. So it's a monthly decay rate of about 3.5%. It had a half-life of 20 minutes. And an annual decay rate of about 3.4%. So these are just changing into several different forms. So now we're going to change it to a continuous rate. A continuous rate is best that we start off with the annual rate. So to convert monthly back into annual, we're just going to take everything inside of this parenthesis, and we're just going to simplify this using our calculator. So we're just going to write 1 minus point. Let me put a fraction here. That'll be more helpful. All right, parenthesis 1 minus 0.034600736. All of that is over 12. I'm going to raise that to the 12th power. Not times 12, 12th power. And we get y equals 500. By the way, you'll notice the 500 doesn't change in any of these problems, right? So 0.96593638289, which is the same thing we had before. So I just converted it, before I converted it from half-life to annual, now I converted from monthly to annual. Now to convert to a continuous format, we're going to write y equals 500 times e to some unknown rate. So this is what we don't know, to the x power. So pretty much we're trying to find out what do we have to write for r for this to equal this. So we're just going to write that equation and we're going to solve it. We're going to write e to the r is equal to 0.9659363289. And we're just going to solve this equation by using a logarithm. So this is our base. So we're going to write log of base e equals 0.9659, not equals that, excuse me. Log base e of 0.965936328 is equal to r. So this is going to calculate our r when we just type this into our calculator. Now, there are a couple ways to do log base e on a calculator. there's a button on your calculator that you can do instead of log base e, which is just called ln. So that's what I'm going to be doing here. So instead of typing log base e, I'm just going to press ln, which is on the calculator. I'm just going to press ln. It's right under log. And just type in 0.965936328 and that will convert to this decimal. So r is equal to negative 0.03465733591. You'll notice I'm not rounding at any point. Not that I can't round, there's no point in rounding until you get to the end of a problem because you don't know how many decimals you're being asked for. So until you get to the end of the question and you know where you want to round to, there's no real reason to round. So writing this in exponential form, it should be y equals 500 times e to the negative 0.03465733591 x. So this function says you have 500 grams of a radioactive isotope that decays at a rate of about 3.5% every minute. So all of these were in minutes. So hopefully you found this helpful for converting to all these different forms. To convert this back to annually, we would just have to take this and type it into our calculator again. And all it would do is bring us right back to where we were a minute ago. And hopefully that was clear on how we do all of those. So that's just converting to all the different forms. A lot of problems on the Regents will have you stop here. They don't always have you convert all the way to this form, but at least you can.